And let's look at the visual physiology of the rods and cones. So rods are photoreceptors. Light is in photons and packets of light energy. Rods are highly sensitive for non-color vision. We mentioned where they're located. Cones are less sensitive but have to have bright light in order to be able to see colors. And that allows for very, very sharp vision within bright light. So what's the photoreceptor anatomy? So if we look at the bipolar cells, we have the cones and the rods that have these discs that store rhodopsin, a molecule in the cell membrane, and as light passes through the ganglion cells, bipolar cells, and reaches the rods and cones, a change in the shape of this rhodopsin molecule will lead to generation of action potentials or hyperpolarization of the rods and cones, and that change in the shape of this molecule generates nerve impulses that are going to be sent to the visual cortex, and thus we have vision. So there's a cycle of the photon hitting all of the rods and cones, changing the shape of this retinol and opsin. They put together the form rhodopsin. When this retinal rhodopsin is exposed to light, it changes its shape, and that causes the release of energy and the stimulation of the rods and cones to send messages to the visual cortex, and then rhodopsin is regenerated, and it's amazing. Everybody knows that bright light can bleach out your awareness of the visual environment. So how does this information from the rods and cones get to the visual cortex? So you're going to have the eyeballs with the optic nerve, the optic chiasm, the optic tract, and relayed by the thalamus and then into the visual cortex in the occipital lobe. Some fibers stay on the same side, so the right side will send information both to the right cerebral hemisphere and the left cerebral hemisphere. The superior colliculus, which we talked about, which is behind the epithalamus, and these specialized structures help analyze and get information to the visual cortex. Okay, let's stop there. Where am I going? Okay, stop recording. Stop.